Common cases in circular motion is what we are going to see. We are going to see first the common cases, then we can see the examples, which are very easy of course. So let us see what happens before you solve it. Okay, when it comes to solving the circular motion problems that are in math are questions. Draw a clear force diagram, resolve vertically, and since the force doesn't move upwards or downwards, the force must balance in that direction. That's what I mean. We are dealing with now horizontal motions in the circle. Now, if the motion is like this, I think you see it's a horizontal, that's all. If it's horizontal, it means that there's no any force that's acting upwards. I mean that there's no motion upwards. So the particle is just in a horizontal, if you can see there. So it's creating a path horizontally. So in that case, we shall see that there is not any movement upwards. So meaning the only force that are acting upwards is the reaction if the body is in contact. For example, if this is the body in contact with the surface, it means that there is going to be reaction and also there is going to be weight of that body. This is the case when we have it there. So always in horizontal circular motion, we don't have any motion upwards. Okay. Magnitude of the A. Write the equations of motion along the radius, as you can see. Then, magnitude of the net force is given by the force we have seen, the centripetal force that is keeping that particle in circular path. Some common situations, particle on a string. If a particle is attached on a string, the other end on a smooth horizontal surface, tension in the string will provide the forward force towards the center. So, for example, this is the case. We have a particle touched. This is the particle touched on one end of and then this one is touched on the string. So, if this one is to move in a circular path like this, the force towards the center, now this is going to be our center, this is our center. So the force towards the center is going to be provided by the tension in the string. Remember, this tension is pulling this particle towards the so that it doesn't go further from it, as you can see when I start rotating it. See? So the forward force towards the center is provided by the tension in the string. Now, this is the case we are studying. Now, the idea we are studying here is this is horizontal. But you say blackboard, of course, it's a vertical, so but it's supposed to be like this. It's horizontal. Now, this is going to be our particle P. So this is going to be our reaction because there is contact between the surface and the particle. Of course, there is going to be weight. So this is the case we are having. So we are going to be having reaction and then weight downwards. So when such rotating in that circular path like that, the force that is keeping it towards the center is the tension in that string. So this is the idea we are having there. Anyway, resolve upwards. This is going to be equal to this, and resolving this. This is the force that is going to be keeping this particle towards the center, which is what we call the centripetal force. But this time is going to be that of the string. Of course, this is this R. Particle on rotating this. Now, if we have a disc here, this is my disc. If it's rotating, if this disc is rotating like this, you see there's a point at the point of slipping. Okay, the force acting on a particle resting on a disc is the frictional force. The only force acting on this particle resting on a disc is what we call the frictional force. Between the surface and the particle. For any disc, there will be maximum friction force and the particle will be at the point of slipping. Slipping means it's going to slide away. Like we've seen, I had a particle, but the particle was at the point. Now you see, here the idea is, if this one is rotating like this, you see the particles are at the point of, because of the motion that is moving, these particles are at the point of sliding. Now, the idea is, the circular motion we are going to base on not that of the disc, but for this particle on the disc. That's why you see that here, if this is the round disc, my step force is from here to the particle. We are considering the force at this particle. When this disc is rotating, say like this, I think you can see it's rotating. So this particle here is the one which is creating strong motion. We are considering, we want to consider the disc No. The disk is round, but we are considering the motion created by the circular path. The circular path created by this particle on the disk. That's the case there. So this is the idea. I think you can see. This is round, but also as it's rotating, you see, as disappeared. Now, that's the case when the friction is at maximum. Before it's slip, friction means it has been exceeded or it has reached its maximum. Okay, 3, particle on the circular wire. Now, this case we have now a wire. This is my circular wire. We attach a particle on the wire. Of course, the wire is going to consider when this is smooth. Now, when it's rotating, say at the velocity v like this, if it's rotating, it means that now the force that keeps this towards the center is going to be given by our centripetal force, as you see there. Still resolving vertically. The only thing when you resolve vertically is going to be this, not any other thing, because there's not any motion upwards and there's no other force acting upwards except this and this. Simple. So basically, these are the ideas we have. We are going to see more cases in the next lesson. See you there.